So what was the question? A boy starts from position A, he moves to B, C, D, and finally comes to position A. So what is the initial position in this case? Initial position is A, and what is the final position? It's same as initial position, that is A. Final position is also A. So let's find out the distance traveled. Distance traveled. So distance traveled is the actual length of the path. So from A to B, 10 plus 5, 15 plus 10, 25 plus 20, 30. So the distance in this case will be 30 meter. Now what is displacement? As I already told, displacement is the shortest distance between initial and final position. Shortest distance between initial and final position. What we see here is the initial position is same as the final position. That means the initial and the final position coincide in this case. So is there any distance between initial and final position? No. There is no distance between initial and final position because these two points coincide. So what will be the displacement? The displacement will be 0. So what we notice here is that distance can never be 0, but displacement can be 0 in case when the initial and final position coincides, right? Now let's move to our next topic, that is velocity. What is velocity? For that, let's take an example. This is a crossroad. We can show the direction: east, west, north, and south. Suppose a thief is on the run. Okay, so he is on a bike and he is being chased by a police. Okay, so you were standing beside the road, and what you saw was the thief moved ahead and he took a right turn. That is, he moved towards east. Okay. Now, when the policeman comes, so he starts questioning that have you seen any person on a bike? So yes, you said yes, I have seen. So again, the police will ask you what was his speed. So you said the speed might be around 40 kilometers per hour. You told the police. Do you think with this minimum information, the police will be able to catch that thief? No, I don't think so. Because when we will reach this crossroad, we will be confused where the thief might have went, towards east or towards west. So with this minimum information, the thief is not going to, he will not be able to catch them. The police will not be able to catch the thief. So again the police comes to you and asks you, what was his direction? So then you will tell that he moved 40 kilometer. He moved with a speed of 40 kilometer per hour towards say east. Okay. So if you see in the first case, you just told him the speed, but in the second case, you told him this speed as well as direction. So this is velocity. This is velocity, and in the first case, it will be termed as speed. Is that clear? So now, what will be the definition of velocity? Just add direction in the definition of speed. What was the definition of the speed? Speed of the body is defined as the distance traveled by per unit time. And what will be the definition of velocity? Velocity of the body is defined as the distance traveled by the body per unit time in a given direction. Simply you have to add direction in the definition of the speed and we get the definition of velocity. Now, We already have discussed, I think, scalar and vector quantity. So what was scalar and vector quantity? Those physical quantity which have only magnitude. Magnitude means a particular numeric value are termed as scalar quantity, and what are vector quantity? Those physical quantities which have both magnitude as well as direction. They are termed as vector quantity. Now, if we see speed, don't you think that speed has only magnitude? It is magnitude. 40 km per hour is magnitude. And velocity, look, it has both magnitude as well as direction. So, it is a vector quantity. Okay. Frequently, question is also asked in examination. What is the difference between speed and velocity? So, it is very easy. You don't have to memorize speed and velocity. I already told you the definition of speed and the definition of velocity. So in the first point, you can write the definition of speed and velocity. Secondly, this whole thing and police story. So speed has only magnitude. So speed will be scalar quantity, and what will be the velocity? Velocity will be a vector quantity because it has both magnitude as well as direction. So it is a vector quantity. So you can write these two difference between speed and velocity. Is that clear? Now, what will be the difference between distance and displacement? Difference between distance and displacement. Let's see, this is also frequently asked in examination. So I think we have already discussed what is distance and displacement. Let's see what will be the difference. So in the first point you can write the definition of distance and displacement, which I think we have already discussed. In the second point, you can we have already taken two examples, and we have also said that distance can never be zero. Distance can never be zero, but displacement can be zero. It can never be zero, but displacement, yes, it can be zero in the case when the initial and the final portion both coincide. Third, distance. Distance is a scalar quantity. Okay, distance is a scalar quantity, right? Is that clear? If this is our initial portion A, and this is our initial portion B, so the distance will be actual length of the path. But what is displacement? Displacement is the shortest path, and it will be a straight line, right, from A to B. We cannot get displacement by going in this direction or in this direction or in this direction. We have to follow a straight line. So here this direction matters. In case of displacement, direction always matters. So a displacement will be a vector quantity because it has both magnitude as well as direction. So distance is a scalar quantity and displacement is a vector quantity, right? So you can write these three differences. Okay. Now let's move to the next topic, that is acceleration. So what is acceleration? So acceleration is defined as the rate of change of velocity. It is actually rate of change of velocity, right? Now what is rate of change of velocity? First of all, let's take an example. Suppose a car is moving with a velocity of say 12 meter per second, right? We accelerate, okay, and the final velocity of the car becomes say 18 meter per second, right? So What is the initial velocity in this case? 12 meter per second. What is the final velocity in this case? 18 meter per second. Okay. From 12 to 18. From 12 meter per second to 18 meter per second, it will take, obviously it will take some time. Okay. Say 3 seconds. Okay, from the from 12 meter per second to 18 meter per second, so the time required is 3 seconds. 3 seconds. So what is the change in this case? The change in this case is 6 meter per second. Okay, this change that is 6 meter per second, this change took place in 3 seconds. This change took place in 3 seconds. So in 3 seconds, there is a change of 6 meter per second. So what do you think? That what is the change in 1 second? What is the change in 1 second? So in 1 second, the change is 2 meter per second. So this is actually acceleration. This is the rate of change of velocity per unit time. Okay. So acceleration can be defined as the rate of change of velocity per unit time. So how we calculate change? How we calculate change? So we can calculate change in velocity simply by subtracting final velocity and initial velocity. So we can calculate the change in velocity by subtracting final velocity and initial velocity. And remember one thing, this will need it when we will solve all those numericals around. Initial velocity is represented by u. Final velocity is represented by v. So what will be the change in velocity? It will be v minus u. Is that clear? Change in velocity, however, for final velocity we represent it by v, and initial velocity we represent it with u. Okay. So for acceleration, we represent in motion, we represent acceleration by small a. So what is acceleration? Rate of change of velocity. So that is v minus u by t. Is that clear? V minus u by t. So let's take a question. The initial velocity of the car was 12 meter per second, right? So its final velocity will become 8 meter per second. In time, what is the time? In time, 3 seconds. So what is acceleration in this case? What is acceleration in this case? So we will use this formula. A equal to, what is the final velocity at 18? Minus, what is the initial velocity at 12? And what is the time? 3. So 6 by 3, 3 to the 2 meter per second square. And remember, the unit of acceleration is meter per second square. Is that clear? Now, why is the unit of acceleration meter per second square? You can just calculate from here. In the numerator, you have velocity. So, what is the unit of velocity? Meter per second. And what is the unit of time? It is second. So, if we solve this, so what we get? Meter by second square. Or we can write as meter per second square. Or we can also write as meter second minus 2. Is that clear? So, in 1 mark, you may also get this question: what is the unit of acceleration? It is meter per second square. So, is that clear? Now, the final topic is average velocity. Now, let's see what is average velocity. Later on, we will be solving numericals, because you will be getting one numerical for sure in examination. So what is average velocity? We represent average velocity is represented by v bar, and that is the sum of initial velocity plus final velocity divided by 2. So this is average velocity. Initial velocity plus final velocity divided by 2, or we can say the mean of initial and final